Hello friends, welcome to Susan and John MathTube. Today we are going to start a new series, and that is the exam preparation series. And these videos are meant only for the first year engineering students who are studying in TU affiliated colleges. And before we start, I'll tell you a few points so that you can use the video lessons very effectively. And the first point is, make sure you do a very good revision with our video lessons. I know it's almost exam time, so you have a rough idea about all the topics. So when you watch the video, I'm sure that you're going to get a very good revision, and in these videos the past paper questions will also be discussed. And the second one, make sure you watch these videos very seriously. Always keep a pen and a paper so that you can work out the problems, and make sure you note down key points like formula, etc., etc. And the third one, once you have finished watching a video, make sure you choose a reference book, any reference books that suits you, and make sure you work out a lot of questions related to the same topic. And the last point, to boost your confidence, this is very important, make sure you take some past paper questions and work out the problems which we discussed in this video. And if you're able to work out the problems by yourself, be very happy you have used the video lessons very effectively. Now let's not waste time. Let's start with the first lesson, in which we discuss partial differentiation. I'm sure that you know the word partiality, or you know the word partial. And when you hear the word partial, you know that we are doing something which is not in a complete manner. We are going to show some partiality, but today we are going to show partiality with the mathematical functions. And before we start, let's take a two variable function. Let's say u is a two variable function in x and y. Then the partial derivative of x is actually the derivative itself. But when we take the partial derivative, we treat x to be the only variable. Or in other words, all the other letters which you see in the question will be treated as constants. And some books use the notation ux, and some books use the letter p. Likewise, when you find the partial derivative with respect to y, you treat y to be the only variable. And if you want, you can write uy or q, and the other quantities are the second order derivatives. And this is actually the second order derivative with respect to x, and this is the second order partial derivative of u with respect to y. But this is slightly different, and I have put one arrow over here. This 2 refers to the second order derivative, but you have to start from right to left. That is, you find the partial derivative with respect to y, and then differentiate that expression with respect to x. Now, if you have a multivariable function in 3 variables x, y, z, then this means we have to differentiate 3 times, and this symbol implies we have to do it partially, and the order is from right to left. That is, you differentiate partially with respect to z, and then with respect to y, and finally with respect to x. However, some books, especially I have seen some American books, following the reverse order. So let's start with an example. Let's say f is a multivariable function, and it's in 3 variables x, y, and z, and the function is given by x square plus y cube plus x into z cube. then let's try to find the partial derivatives. Okay, the first thing I want to tell you is, if you want, you can write f as f of x, y, z to be very clear. But if you want, you can just use f, because it's obvious that it's a function in x, y, and z. Now, when I write like this, it means I have to find the partial derivative of f, and I have to treat x as the only variable. And if I treat x as the only variable, then all the other letters will be treated as constants. So the derivative will be 2x, and this is a constant, and the constant will be 0 once differentiated. And look at the last one. This part is a constant. So I hope you remember, if you want to differentiate a constant multiplied by a variable function, then what you do is you keep the constant and differentiate the function. Likewise, if you have something like 5 into x, the derivative will be 5 into 1, because the derivative of x is 1 and 5 is a constant. So the derivative will be 2x plus 0 plus this is a constant and this is a function. So we get, okay, and once simplified it looks like this, and I'll write it on one side. Okay, now let's go for the partial derivative of f with respect to y. And when I write this notation, you have to understand we are going to do partial differentiation of the function f with respect to y. Or in other words, you are going to differentiate this function by treating y as the only variable. Okay, if y is the only variable, all the other quantities which I see here will be treated as constants. So the derivative is going to be 0 plus 3y square plus again 0. So that's it. I'll write the answer here. And now let's go for the last possibility, that is the partial derivative of f with respect to z. So like I told you before, who's the hero? Yeah, z will be the variable, and x and y will be treated as constants. So the derivative will be 0 plus 0 plus, oh, we have a constant into function situation. I told you, if you have a constant and a function together as a product, you keep the constant and differentiate the function. So the answer will be 0 plus 0 plus this quantity, and simplifying we get this. And now let's go for some second order partial derivatives. So look at this. I can understand its partial derivative, and I can understand the order is 2. That means I have to differentiate 2 times. The first time I will differentiate with respect to y. We already done that. And then I will differentiate this expression with respect to x. So I'll put an arrow, and the meaning, so we have this quantity in light blue over here, and I have to differentiate it with respect to x, but there is no x over here, and x is the only variable, so the answer is 0. Now let's try another possibility. So this symbol tells you we have to differentiate partially, and the order is 2. That means you have to differentiate 2 times. The first time it will be with respect to z. So we have the answer here. And then with respect to y. And I'm not able to see any y over here. So it's a pure constant in this situation. So like before, the answer is 0. Now let's go for the third possibility, the second order partial derivative. Okay, and like I told you before, I have to differentiate with respect to x, and then I will differentiate with respect to z. We have the derivative with respect to x here. Now I have to differentiate this expression by assuming z to be a variable, and that will give me 0 plus 3z square. That's it. So now let's go for the second question, that is, if u equal to x square plus y square by x square minus y square, find the partial derivative of u with respect to x and the partial derivative of u with respect to y. I'll write the question here so that you can refer anytime. Okay, so let's write the function. Now look at this. The rules of differentiation and the rules of partial differentiation are the same. That means you're not going to study anything new, but you have to change your perspective. Earlier, in your high school level, your functions used to be in one variable. But now we will meet functions in one variable, or maybe two variables, or maybe three variables. And partial differentiation starts with functions from two variables and maybe three variables, etc. Okay, so we have a function in two variable, and we have to find the partial derivative of u with respect to x. And I can see x in the numerator as well as denominator. So I have only one option, that is the quotient rule. And when I differentiate, I will assume x to be the only variable, that is, I will treat y as a constant. So denominator into partial derivative of the numerator. Look at this, 2x plus 0, because y is a constant for the time being, minus numerator into derivative of the denominator, that will be 2x minus 0, the whole divided by denominator square. And let's simplify this a little bit. So I'm writing 2x over here, and now 2x will come common, and some cancellation, and finally you can add all those things and you'll get this. Okay, now let's go for the second part, that is the partial derivative of u with respect to y. I'll write u first, and now I'm going to reduce the steps, and if you want you can pause the video for a minute and try it yourself and compare with my answer. So I can see y in the numerator as well as in the denominator. So here it goes. So remember, we are going to differentiate partially with respect to y, and when you differentiate partially with respect to y, y is the only variable. So that's why I got this as well as this. So denominator, derivative of the numerator, minus numerator, derivative of the denominator, the whole divided by denominator square. And of course, now you can take 2y as common, and once simplified, you'll get this. Now you can check it out with your answer. I hope you're okay with it. Now let's go for another problem, the third one. And I've seen these questions in many past exams, so please mark it very important. So if u equal to log of x cube plus y cube plus z cube minus 3xyz, then prove that, we have a long expression here, sum of the partial derivatives being 3 by x plus y plus z, and then we have an operator over here, the whole square operator. Okay, anyway, I'll write the question here so that you can refer anytime. Okay, so let's start. But before we start, a small note. Look at this. This is a symmetric expression. Symmetric expression means if you replace x with y and y with z and z with x, there will be no change in the function. So look at this, I'm going to put y here, x here, z here. Same thing here. So the function did not change. In a symmetric expression, whenever you are supposed to find the partial with respect to x, the partial with respect to y, and the partial with respect to z, don't waste your time. Just find one partial derivative and move in a cyclic manner. Anyway, let's start. So, look at this. U is equal to log x cube plus y cube plus z cube minus 3xyz. By the way, what is the derivative of log x? I mean ordinary derivative, ordinary differentiation. It's 1 by x. So what might be the derivative of log something? That will be 1 by the same quantity. And then, according to chain rule or function of a function, you have to differentiate that particular quantity. Okay, so are you able to see log something? So log something once differentiated will give you 1 by the same thing, and then you have to differentiate this quantity. Wait, we are doing partial derivatives, and that means x is the only variable, and that's why I got 3x square plus 0 minus 3 y into z. Okay, now similarly, I told you in the beginning itself it's a symmetric expression. I'm not going to waste my time evaluating the other partial derivatives. I simply replaced x with y, y with z, and z with x. And the same story repeats. So now I have the partial derivative with respect to x and y and z. Now my job is very simple. I have to add them up. And when I add them up, I can see that we have a common denominator. Now I can see there is something common in the numerator. Okay. Now we have a very important step. And that is an identity which you might have studied in your high school. So look at this. This denominator can be factorized like this. You have to remember this. This is a key step, and if you forget this, you're never going to get the answer. So make sure you note this identity. Anyway, that's it. We have the answer. Okay, let's move ahead and go for the next question. That is the second part. Okay, I hope you remember the operator d square means you have to apply the operator 2 times, or rather you have to differentiate twice. And take a look at this. We have the partial derivative operator being squared, and that means we are going to apply the operator twice. And once you write this, you're ready to take this u inside. You can start the operation. Okay, so that will be partial of u with respect to x plus, and that is exactly the first part. Take a look at this. And we have already evaluated the first part is 3 the whole divided by x plus y plus z. Now this operation is complete. Now let's start with the next part. That means this. Okay, now one very important thing. Note that the derivative of 1 by x is minus 1 by x square. So if you have something like 5 by x, 5 by x is actually 5 into 1 by x, and 5 by x differentiated gives you 5 into minus 1 by x square. I told you before, this is a constant and this is a variable function. So you end up with 5 multiplied by minus 1 by x square, or that is minus 5 by x square. Applying the same logic, if you have something like 3 by something, then the derivative will be minus 3 by something square, and then the derivative of that something part. Okay, so look at this. We want the partial derivative of x of this function. It looks like 3 by something, a variable is here, and that will yield me something square, and then the partial derivative of x is 1. And that's it. That's the end of the second part. Okay, so let's move ahead. And one more very important question from your past paper, and that is u is equal to 1 by x square plus y square plus z square. Prove that the sum of the second order partial derivatives is equal to 0. Okay, now before we start, you can be very happy, even though this expression looks a little bit complicated, because you know the derivative of root won't be that nice. It's a symmetric expression. That means if you replace x with y and y with z and z with x, it's not going to change. You're going to get the same function. And you want the second order partial derivative with respect to x and then y and then z. But don't worry, we will find one and then we'll write similarly the other two expressions. Okay, now let's start. I'll write the question here. Anyway, I don't like this square root, so I squared on both sides. And I hope you remember 1 by a to the power n is a to the power minus n. So I'm going to cross multiply and apply these things, and I end up like this. Okay, now remember, u is a dependent variable. If you look at the question, you will understand u depends on the independent variables x, y, z. I'll repeat, u is a dependent variable and it depends on x, y and z. So now let's differentiate partially with respect to x, and when you do that, never forget u is a dependent variable, and the derivative of x to the power n is n x to the power n minus 1. So when you differentiate x to the power minus 2, you're going to get minus 2 x to the power minus 2 minus 1. So applying similar logic, you get minus 2 u to the power minus 3, and this is that dependent variable special, dou u by dou x is equal to 2x. Now cancelling out on both sides, you get this, and let's do some cross multiplication, and that's it. But take a look at the question. We want the second order partial derivative. That means we are going to differentiate again with respect to x. Now this is very important. When you differentiate again with respect to x, don't feel u is a constant. Remember, I told you u is a dependent variable. Even though you are not able to see x here, x is hiding. Now, are you able to see x inside this expression? Yeah, yes. So, we must apply product rule. So, let's differentiate partially with respect to x. First function, the derivative of second, and I told you the dependent variable special plus u cube into 1, and that's it. You can substitute this value here, and that's it. Now simplify, and that will be okay. That's it. Now I'm not going to waste my time and find the partial derivative with respect to y and then the second order partial derivative with respect to y. Instead, I'll write my favorite word, similarly. And why am I able to write similarly? Because the question is a symmetric expression. So look at this. I just replaced x with y and y with z, and I found the other partial derivatives. And now let's add them up, because that is exactly what they asked us to do in the question. So once you add this plus this plus this, I hope you can notice that 3u to the power 5 is common, and I hope in the beginning of the question we found that x square plus y square plus z square is u to the power minus 2, or you can check it out over here. If you square this, cross multiply, etc., and apply a power m into a power n is a power m plus n, you can apply that over here. That's it, is equal to 0. Okay, now let's move ahead. Wow, we have another symmetric expression, and please make sure you read this as said, not to. Okay, so we have the function is equal to e to the power x by y plus e to the power y by z plus e to the power z by x. And you're supposed to prove, please read this as prove that. Okay, that's again a symmetric expression. Are you able to notice that symmetric expression everywhere? That means I'm going to find just one expression, and then I'll write my favorite word similarly. So let's not waste time and start. Okay, so tell me, what is the derivative of x? Yeah, it is 1. So if you want to differentiate x by 5, if you want, you can write this as 1 by 5 into x, and that will give us 1 by 5 into 1, and that will be 1 by 5. That means if you differentiate x by 10, the answer will be 1 by 10. Now let's think about the reciprocal 5 by x. I hope you still remember the derivative of 1 by x is minus 1 by x square. So this 5 by x is 5 times 1 by x, and differentiate and once differentiated it will give me 5 into minus 1 by x square, and that is nothing but minus 5 by x square. So if it is 10 by x, the derivative will be minus 10 by x square. Okay, you can keep all these things in your mind. I want you to read the question once more, and let's start with the partial derivative of f with respect to x. Okay, so I have f here. I'm going to rearrange a little bit so that the differentiation will be very comfortable. So the partial derivative of f with respect to x. So I hope you are able to see the chain rule again, e to the power something. So according to our chain rule, it will be e to the power the same thing, and then the derivative of that something part. Okay, so e to the power same thing and then 1 by y. Now we are differentiating with respect to x, so x is the only variable, so this is a pure constant, and finally e to the power same thing and then z into minus 1 by x square. Let's simplify this a little bit. Now I want you to take a look at the question. We want partial derivative with respect to x, but we have to multiply with x. So I'm going to multiply throughout by x. I'm going to multiply throughout by x and simplify, and that gives me this. Okay, that's it, my friends, because I told you in the beginning this is a symmetric expression, and in a symmetric expression don't waste your time by evaluating these quantities again and again and again. Write the word similarly, replace x with y and y with z and z with x. Okay, now we have our required expressions. Now let's add them up. It's obvious, if you add them up, these two quantities are going to get cancelled. These two quantities are going to get cancelled and we are going to get 0. Okay, that's it. Now let's watch something very important. Okay, I hope you remember the two systems which is used to plot points in a plane, the Cartesian system and the polar coordinate system. And I'm sure that you know the conversion. This will actually convert the points in polar to Cartesian. And these formulae will transform the points in Cartesian to polar. Anyway, my point of interest in this video is different. We are learning partial derivatives, so let's check out this particular character. So I hope you can see that R is a dependent variable. R depends on both X and Y. So let's learn how to differentiate this partially with respect to X and similarly with respect to Y. So I hope you still didn't forget how to differentiate a dependent variable. So it's like 2R and the partial derivative of R is equal to 2x, cancelling 2 on both sides. Okay, so please note this point. And now the most important part, the second order derivative with respect to x. Are you able to see x in the numerator? Yes, of course. Are you able to see x somewhere in the denominator? And I'm sure most of you will feel that there is no x in the denominator. But don't forget, r is a dependent variable. R is actually x square plus y square. R depends on x and y. So even though you are not able to see x in the denominator, there is x. So if you want to find the second order derivative, you must apply quotient rule. This is very important. So denominator into 1 minus numerator into partial derivative with respect to x, the whole divided by r square. But we already know that the partial with respect to x is x by r. So replacing, then taking LCM and simplifying a little bit, and I hope you remember r square is x square plus y square, cancelling out things. Okay, that's it. So please note this. Now look at this. If you want the partial derivative of r with respect to y, you don't have to do all these things. Just write y by r. Similarly, if you want the second order partial derivative of r with respect to y, it's so easy, you just write x squared by r cube. So I want you to note all these things. Okay, now let's go for a question related to the polar coordinate system and partial differentiation, of course. So if x is equal to r cos theta, y equal to r sin theta. So look at this, they are mentioning the polar coordinate system and the Cartesian coordinate system together. Prove that. We have a lengthy expression over here. You can read it. I'm lazy to read that. And as always, I'll put the question over here. So please note these points. I already gave you the proof, and if you want, you can note one more thing. The partial derivative with respect to y is y by r. We proved this, and no need to prove these two quantities because the expression is symmetric. So shall we start? Okay, so we have the values over here. I took the left hand side and plug in those values. The denominator is common, and I still hope you remember r square is x square plus y square. That's it. So the left side is 1 by r. Now let's consider the quantity in the right side. inside the bracket. Yeah, we know the value x by r and y by r. Substitute, square them up, the common denominator, and the numerator is r square, that is 1. So the right side will simplify to 1 by r into 1. That's it. Now you are in control of this question. Okay, now let's go for one more question, a little bit important than this. So if u equal to f of r, again it's mentioned it's a polar function, then prove that the second order partial derivative of u plus second order partial derivative with respect to y, the sum of the partial derivatives is this. So remember, u equal to f of r actually implies the function is associated with the polar coordinate system. Again, you have to remember that r is root under x square plus y square, that is r is made up of x and y, r depends on x and y. So you can imagine this is a function in x and y. So the partial derivative of x, the partial derivative with respect to y does make some sense. So as always, I have kept the question here. So let's start with the given function. Now remember, r depends on x and y. So when I differentiate with respect to x, the partial with respect to x will be f. The derivative of f will be considered as f dash times, do you remember the trick for the dependent variable? Yeah, partial with respect to x. But we proved earlier what is the partial derivative of r with respect to x, x by r. It will be really nice if you prove this for your exam, and substituting we get this. We are ready with the first order partial derivative with respect to x. Now you have to be extra careful when you find the second order partial derivative. Look at this. This function depends on x as well as y. Even though you cannot see, this function depends on x. And here it is clearly written x, so it is a function in x. And again the denominator depends on x as well as y. So let's try differentiating. Okay, that's it. I'm going to apply product rule. So the first function as such and the derivative of the second. And remember, I can see x in the numerator as well as the denominator. So you must apply quotient rule. And I hope you remember these values. It's over here. Okay, plus the second function multiplied by the derivative of the first. So that will be f double dash r and the derivative of the dependent variable. Now it's almost done. Let's substitute, take LCM, simplify a little bit, and always remember r square equal to x square plus y square. And that's it. We have the second order partial derivative with respect to x. Now I'm going to write my favorite word. No, I'm not going to write that, but I'll write the second order partial derivative of y is equal to, yeah, see, I just changed y into x and x into y. That's it, I got the answer. Now take a good look at the question. We have to add them up. And when you add these two quantities, I can see that this will come common and this is r square, and when you add these two quantities, this will be common, and that's it. I'm sure that you can handle this. Okay, so I'm planning to stop the video right here, and I'll be back with the next video tomorrow itself, and I'll keep on uploading the videos till your exam date. And if you find these videos useful, please do like, share and subscribe. And if you have any doubts regarding the topic which we discussed just now, I may have missed some points which you want to explain once more, please feel free. You can comment below, and we'll meet tomorrow with the second part where we will be discussing total derivative and the applications of partial differentiation. And again there will be a third lesson, and in which we will be working out problems on maxima minima. And once the 3 videos are completed, we'll complete approximately 10 marks. So I'll be back tomorrow. Till then, bye.